Welcome back, Wildcats. All right, so today we're looking at Monday, January 23rd, square root inverses. And that's going to be on page 46. So if you would, pause the video and update your table of contents. All right, now that your table of contents are updated, let's take a look at our notes. All right, so when I was thinking, I was like, man, what am I going to do? How am I going to find notes for this? So what I realized is we already have notes on inverses in the function folder. Okay, so what I realized when I looked at our notes, that there were 4 ways to find the inverse function. Okay, and let's look at them. Number 1, we look at the graph. So you take the graph and you reflect over the y equals x line. 2, you take the table and you switch the x and y. Number 3, the algebraic is you switch the x and y and resolve for y. Now, before I go into 4, let me just go back and note, as you notice, I put a note here. F of x equals y. So when we say switch x and y, you could also say switch x and f of x. All right, and the 4th way is compositions of functions. So when f of g of x equals x and g of x equals x, when this happens, when you get f of g of x and g of f of x equals x, then we know that f of x and g of x are inverses. And just a note that when you find the inverse, the domain and range will be switched. All right, so if you would, update your notes. All right, now that your notes are updated, let's take a look at example number 1. All right, so in the examples, I'm going to use 3 shades of blue: pink shade of blue, purple shade of blue, and yellow shade of blue. All right, so I'm going to make the original function pink, and I think this is Posh Pink, which is my favorite shade of pink. Okay. All right. Now, I know in the ways it says, we'll reflect this over the y equals x, and you could do that, but an easier way is to make a table. So we're going to make a table using the points. All right, so the points are 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so now we know to find the inverse in the way number 2 is to switch x and y. So we're going to make a new table. All right, so the new x values are going to be 0, 1, 2, 3. And the new y values are going to be 0, 1, 4, 9. Okay, so when we graph those, 0, 0, 1, 1, 2, 1, 2, 3, 4, and 3, 9. So 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so if in fact these are inverses, then they'll reflect over the y equals x line. So using yellow, we're going to graph that. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. All right, you'll see that they reflect over the y equals x line so that they are inverses. All right, so what I'd like you to do now is pause the video, and I want you to work example number 2 on your own. Okay, then once you've worked it, then I want you to press play, and then you'll check your work with my work. All right, so I assume if you're watching at this point, you've paused the video, you tried example 2, now you're going to check your work. All right, so again, I'm going to make the original function Posh Pink, which is a shade of blue. Okay. All right, so I need to make a table. So again, x, y. All right, so 0, 3. see 1, 4, 1, 2, 3, 4, 5, and then 9, 6. All right, so to find the inverse, we're going to switch the x and y. So we need to make a new table. All right. So the new x will be 3, 4, 5, 6, and the new y will be 0, 1, 4, 9. All right, so let's graph that. So 3, 0, 1, 2, 3, 0, 4, 1, 5, 1, 2, 3, 4, and I'm going to purposely make a mistake here in just a second, and then 6, 9. Now, I'm hoping that you just caught my mistake, and I did it on purpose because if you ever put the wrong point, you can just put an X over that point, okay? So 6, 9. So 1, 2, 3, 4, 5, 6, up 9. All right, so we're going to check to see if they're inverses by graphing the y equals x line. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. All right, you'll see that they reflect over the y equals x line, so they are in fact inverses. All right, so at this point, I'd like you to pause the video and work example 3, 4, 5, and 6. And I think, and I'll go over those in class, but I think you can try them now. That way, you'll just be checking them in class tomorrow. Okay. All right. So let's look at this. Now, there's a mistake on here. The instructions should say, find the inverse of each function and state the domain and range of each function. For both functions. All right. So what I think you should do is kind of separate this by little boxes like this. And then on the left side, you're just going to write domain and range. Okay, and you're going to do that for each of these. Okay. Now, that's all I want you to do for example 7, 8, 9, and 10, because I think if I try to explain it on the video, I think you'll get more frustrated, not because I'm going to use the Inspire, and if I were you, I'd get frustrated if on the video the teacher's using Inspire, but I don't have one with me. So we're going to do examples 7 and 8, 9 and 10 in class. Okay. All right, let's look at example number 11. It says determine by composition of functions whether each pair of functions are inverses. Okay, so we're going to do first, and I think I'm going to use, since I have some colors available, I'm going to use pink and purple. So I'm going to do f of g, which equals f of g of x which equals the square root of x minus 1 squared plus 1. Okay, so what we know is that the square root in these become to the first power, and then negative 1 plus 1 is 0, so this equals x. Okay, so far we're saying they're inverses. Now we need to do g of f. So that's g of f of x so that is I'm purposely using color so you can see where things go. All right, so you'll see that the plus 1 minus 1 cancel, and that the square root of x squared is x. So you can now say that f of x and g of x are inverses. All right. So with that, try example 12 before you get to class tomorrow. And actually, I guess if you're watching this on Friday, maybe not tomorrow, but on Monday. Yep. So with that, have those examples prepared, ready for class. And with that, have a nerderific Wildcat day.